So in the last two lessons, we talked about different things on the coordinate plane. So today, we're talking about rotations, how things rotate. Yesterday, we talked about transformations and translations, where things move, right, and reflect. So we've talked about reflections, we talked about translations. Today, we're talking about rotations. And the next few days, we'll talk about dilations. We're going to talk about all kinds of different things that are happening on the coordinate plane. So today is rotation. So I have 3 vocabulary words we need to write down. And then what I want you to do when you write your vocabulary, I want you to leave some space in between, because I'm going to talk about some of these different things, and I'm going to have you put some things in between. So the first one is rotation, second one is angle of rotation, and then the third one, if I can move that out of the way, is center of rotation. Guess I can move this up just a little. There you go. So just leave a little space in between, and I will talk about those things. All right, so the first thing I'm going to talk about is rotation. Okay, so rotation is turning around a point. Okay, so it's just turning. So now when they talk about rotation, a lot of times they'll say what kind of rotation. They'll say like clockwise or counterclockwise. And this is term is used a lot in life. So clockwise is when your finger is going to move like the hands of the clock. So it would go like this way. Okay, so it would go this way. Counterclockwise is the exact opposite, where it goes the other way. So it's going to give you 2 things here. It's going to say like, okay, I want you to go counterclockwise 90 degrees or counterclockwise 180 or whatever. So it's going to use those 2 terms. And you have to know what those 2 terms are. Like I said, these are used a lot in life, not just in math. Sometimes, like if you have to get a screw loose, maybe you have to say turn counterclockwise or clockwise or whatever. So this is actually terms that are used in real life. Okay, angle of rotation, they're going to tell you 4 different things. They might say rotate it 90 degrees. They might say rotate it 180 degrees. They might say rotate 270 degrees or 360. For the most part, we're going to be dealing with these 3 today. Okay. Now, what does that look like? Well, a 90-degree angle is just turning like 1/4 way. 180 would be turning what? Just halfway, yeah. 270, 3/4 way, and 360 would be the whole circle. Now, they might say like I made all my marks, this is clockwise, but they might say, well, 90 degrees counterclockwise. Well, in that case, then it would be just like this. Okay, so they might say certain things, so you have to be prepared. So 90, 180, 270 are the things you're going to see the most. Then the last thing, center of rotation, this is where the point turns around. Now they're going to ask you to rotate that thing two different ways today. They're going to say, rotate this figure or this triangle around the origin. And they might say, okay, they also might say, rotate it around a certain point. Okay, for example, I'll show you an example so you can see. Okay, everything's going to be down in coordinate plane. If this would be my figure, and they say rotate it around the origin, that's not a very okay. And if they would say rotate this 90 degrees around the origin, well, in that case, it's going to rotate around here. So it's going to show up in this quadrant. So it would probably look something like this. Okay, that's around an origin. That's like taking it and just like moving it around here. Okay. Now around a certain point, that's a little more tricky. Around a certain point would look like this. So if this is my figure, and this is my point, usually they'll name them like A, B, and C. And they'll say, okay, I want you to rotate this around point A. Well, if that's the case, this is what it's going to look like. Let's see, it's going to rotate like this. That's about what it would look like. They're just rotating. They're keeping this point, and it's rotating just around that point. So you can see the difference. If it's rotated around the origin, it's going to show up in a different quadrant. If it's rotating around a point, it doesn't matter what quadrant it's in. It's just going to rotate around this point right here. And I'll show you how to do some of this stuff. Okay. All right. So, if you're rotating around the origin, like this one, there are certain rules we can follow, which makes it really simple. Like, just like we did the other day, oh, if it's a reflection, you change the x's or the y's. There's certain rules for this as well. So, here's 3 rules you need to know. So, I have 3 rules. We'll start with this one. So, what I want you to know, though, you have to make sure you have this in your notebook, because these are just for going around the origin. Because, like I said, not everyone's going to be like that. They might have a fixed point, but if you're going to go around the origin, these rules will work. Let me know when you want me to move it. Actually, I'll move it now a little bit. I don't know why. Let's do it. Okay. Let me know when you want me to move it up. Notice how these two are the same, even though they're different. 90 degrees clockwise is the same rule as 270 degrees counterclockwise. Notice those are the same rule. Can I move it up a little bit? Are you guys okay with that? So I go like this. Is that okay? These are not in your book. So if you don't have your notebook with you, you will not be able to find these in your book. They are not there. practice these in a little bit. So you can see how they work. That ready? 2 seconds here. Does anybody know I can use the same rule for like 90 degrees clockwise and 270 degrees counterclockwise? Why can I use the same rule for that? Alex?
Because you'll get the same point.
Yeah, you're going to get the same spot. So like if I say, okay, let's go 90 degrees clockwise, we're going to end up there. But if I say, oh, go 270 counterclockwise, guess what? We end up at the same spot. That's how you can use the same rule for this one, and you can use the same rule for this one, because you're still going to end up in the same spot. Whether you go straight or whatever way. That's why that works. Anybody still need this? Can we practice? Can we practice? Okay, let's practice if you run the origin. So this is how it's going to look. It says graph the rotation of triangle ABC 90 degrees clockwise around the origin. So this is where you go back to your table and you say, okay, 90 degrees clockwise. What is my rule for 90 degrees clockwise? I'm pretty sure it's multiply something by -1. Guys, I don't have it memorized either, so what is it? Multiply what? Both? By -1? -90 clockwise, right? Multiply each x coordinate by -1, then switch. Is this what it is right here? Multiply each x by -1, then switch the x and the y. Okay, multiply. So multiply the x coordinate, -1, and then switch. So let me show you how to do this in steps, otherwise it's going to get too confusing. So here's my original. Here's what my original coordinates were. So I'm going to do this first. If these are my x's, I'm going to multiply all my x's by -1. Do you need a second to write down quick, or can I go on? Okay, so here's what it would look like then. It'd be 4, 3. It would be -1 times 1, -1 would be 1, 1. And this one would be 4, 1. Does everybody understand how I got those? I took my x's and I multiplied it by -1. -1 times -1, 1. -4 times -1, 4. Okay, but I'm not done yet. What's my next part of my rule say? To switch them. Now I got to switch them. So, take a look at this part. So this is what it's going to look like then. 3, 4. 1, 1. And then what was this one? 1, 4. That's what it's going to look like. For my, these are my new coordinates. If I was going to graph it, it would be rotating around the origin 90 degrees clockwise. I feel like I need to show you what that looks like. So -4, 3. This was A. -1, 1. And -4, 1. Okay, so here's my, that was my original. Okay, now here's it rotating. 3, 4. 1, 1. And 1, 4. This is my new one. This is the old. This is the new. See how it's rotating around the origin? That's what it would look like. Okay. How are we doing? So far, so good? Okay, you try one yourself now. You try one yourself.
I just write this thing down quick.
Sure, go for it. Go for it.
Almost done.
No, you go. You tell me what you need. Honestly, I need to read it more and take this board. Look how far away that is from my finger.
Okay.
Okay, all right. You try this one by yourself. It says graph the rotation of triangle, this triangle ABC, 90 degrees counterclockwise around the origin. So now you have to go back to your rules for, okay, what's the rule for 90 degrees counterclockwise? And then you need to apply it to the old points. I'm guessing it's multiply y by -1, and then switch again. I'm guessing that's what it is. Because if we multiply x before we went clockwise or when we went counterclockwise, I'm guessing it's multiply the y by -1. Okay, this is terrible. I'm going to do this. There we go. So, first one will be like this. Then, you're going to do it, you got to switch it. Okay. Look good? Okay, and that'll be your answer. What questions do you have for me for anything around the word? Anything? Follow the rules. If you follow the rules, it's foolproof. If you follow the rules, it's foolproof. So make sure you're following them correctly, and you make sure you're following, you know, if it says clockwise, make sure you're looking at the clockwise one. If it says counter, make sure you're looking at the counterclockwise one. Okay? Any questions so far? Okay, so now I told you before that we're also going to have to go around and fix points. This is the hardest thing to do because there's no rules for it. The reason why there's no rules for it is because they don't know, like, at least the origin is going to be there on every single graph. We don't know what point it's going to tell us to turn it around. That's why there's no rule for it. Like, so we actually have to think about it a little bit. So if you want to, you can sketch this on your, if you want to sketch it on your notebook, you can sketch it. I have it so it's just like 0, 1, 2. So this would be 0, 2. This would be 2, 2. And this would be 1, 1, 2, 3, 4. And I'm going to label it A, B, and C. Okay, so this is a fixed point. No rules. You're going to have to visualize some things. If you're not a good visualizer, I have a solution for that. But I'll show you what it looks like to visualize it first, and then I'll tell you my solution if you can't do that. Because I get it. This is the hardest thing to do today. So let's say I'm going to rotate this around point A. Rotate around A 90 degrees clockwise. Let's do clockwise. Okay. So we're going to rotate this whole thing 90 degrees clockwise around point A. So the first thing I have to do is I find a line that's connected to A, especially a straight one. A straight one is the easiest thing to move. So I say, okay, if I'm going to take this and I'm going to rotate this 90 degrees, I'm going to take this and I'm going to rotate it once like this. That's 90 degrees. So this line would now be like this. Okay, that's this line, just rotate it this way. Well, then what does that leave this then? Right here. There's my new figure. Okay, just rotated that. It's like me taking this, and I can rotate it down. Ooh, nope. And rotate down. Yeah, it's like me rotating this way and moving it down around that point. Okay, so rotating it this way. You have it here. Okay, now I can get it back. Seriously. Okay, anyway. Let's try another one. Okay, let's try another one. I had the same problem before. Can't get it. All right, so I'm going to do another one. If I can get it, that would be good. There. I'll get out of there. Okay, let's do another one. Let's make a triangle like this. Okay. If you want to watch, that's fine. I'm going to say, okay, this is A, B, C. And I'm going to rotate around A again. I'm going to rotate 90 degrees around A. So I find something that's straight with A, this one or this one, it doesn't matter to me. So I would take this one, rotate that 90 degrees this way. That's going to look like this now. Let me use 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's this line. Okay. Then what happens? This is going to rotate 90 degrees also. So this is going to look like this. And be connected like that. That's what that would look, rotated 90 degrees around point A. If it's hard to do, that's hard to do in your head. I had a student in the other 8th grade class who actually took a piece of paper, cut it out, and rotated it so she could see what it looked like. That's a good solution. If you cannot see it, find a piece of paper, copy it, cut it out, and actually rotate it and see what it looks like. That's an easy solution if you need some help. Like I said, there's no rule for this. This is the only way I can show you is by having you think about it, because I can't think about it for you. So the only way I can have you look at this and learn it is just by thinking about it. I don't really have a good way to teach it because there's not a rule for it. You just have to think about it. Okay? There's only 1 or 2 on your homework about this. The last thing I want to talk about is one more vocabulary word, and it's called rotational symmetry. We're almost done. Hang tight. We're almost done. We're almost done. Okay, rotational symmetry is when a figure can be turned less than 360 degrees and match the original image. This is on the fritz today. You rotate it less than 360 degrees around the center of the image, and it matches the original figure. So I have 2 things up here. All right, so smiley face doesn't have rotational symmetry. Let me show you why. I can turn this thing, and it doesn't ever look like a smiley face again until I turn it back to 360 degrees. So this does not happen. It has to look like the same thing before you get to 360 degrees. Now, if I look at my snowflake here, pretend these people aren't there. Would this have rotational symmetry? Could I turn it and it would look like the exact image? Yeah, I could turn it till about here, because these are look the same, and here, and here, and here. So 1, 2, 3, 4. So I could turn this exactly 4 times, and it would look exactly like the image that it started at. Now it might ask you, well, how many degrees can you turn it before it looks like the same image? Well, it's pretty simple. You would take 360, because that's what it takes for a whole circle. Well, how many times could I turn this? 4. 360 divided by 4 would be 90. So I could turn it 90 degrees, and it would fall on the same figure. That makes sense to everybody? So here's another one. Let's do a star. A star. Would a star have rotational symmetry? Yeah, it would. Okay, well let's figure out the degree then. So I could turn it here, be the same here, 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 here. So how many times could I turn it? 5. So 360 divided by 5, I believe, is 72. So I can turn it 72 degrees, and it will look the same. That's all. That's it. The end. The end. Now I need to get your book.